Okay, so we've got the value here of an electronic component, maybe modeled as a continuous variable, okay, and it says the value of the component at time t years is p pounds, okay. The rate of decrease of p is directly proportional to p cubed. So basically, the value of this component is decreasing, yeah, and the rate at which it's decreasing, in other words, dp by dt, okay, so that's what it means by the rate, okay, the rate of change, the rate, how it's decreasing over time, right, it says it's directly proportional to p cubed, right, but it's going to be minus p cubed because it is decreasing, okay, so it's going to have a negative gradient. If you think about this, if this was a curve p here, of course the price is going down, so it'll be negative going down, so it'll be negative gradient, so that's why it's proportional to negative p cubed. We must have a minus there to show the negative gradient. So to get the differential equation then, you need to sort of have an equals, don't you? So we'll introduce a constant of proportionality, which would be k, right? And then, so that's your part A answered. So then to get all this then in part B, we need to separate the variables, okay? Okay, so we get the p cubed here, because it's k times p cubed. Take the p cubed over and divide. And then the minus k that's there, take the dt up. We're going to integrate them both sides, okay? So then integrate both sides. Now that's going to be 1 over p cubed, so I need to take that up. So be p to the minus 3 dp before I integrate it, and then we've got that there. So p to the minus 3, well, add 1 to that, you get minus 2. Divide them by the same power, minus 2, okay? That will equal to then minus k t, that's what that will become, plus then my constant, okay? So we can tidy this up then. P to the minus 2 we can bring down, okay? So we p squared on the bottom, so we have 1 over minus 2p squared equals to minus kt plus c, alright? Then the question says, of course, when t is 0, the price is £20, yeah? So we've got those conditions there. So when t is 0, price is £20. So we can sub that in. So we have 1 over minus 2 times 20 squared, and that will equal to minus k times 0 plus c. So that implies then c will equal to 1 or minus 1, because there's a minus there, over 800. That's what that becomes. So therefore, we've got 1 over, or minus, we put the minus there, 2p squared equals to minus kt minus 1 over 800. That's by subbing the c value back in. Now, I'm missing the square down there. Now, of course, they're all minuses here, so I could change all the signs, couldn't I? Because they're all minuses. So I've got 1 over 2p squared equals to kt plus 1 over 800. Let's just compare that to my answer. Okay, let's compare that to my answer. My answer is there, isn't it? Okay, so I've got, let's see what I've got so far, compare it with the answer. So I've got 1 over 2p squared equals kt plus 1 over 800. Okay, now it's very similar, but this is 1 over p squared there. I've got 1 over 2p squared here. So if I times through by 2, okay, so I'll times through by 2, so I'll have 2 over 2p squared here equals 2kt here plus 2 over 800. Now times through by 2, because I know then those 2's would cancel. So I get 1 over p squared equals to 2kt plus then, and that would simplify to be 1 over 400. Okay, and essentially then I get that there. Now you might be thinking, well, actually you've got 2k, yeah, you've got 2k here, and they've got a there, but that's okay, because k is a constant, isn't it? If k is a constant, well, 2k will also be a constant. So we can just rename that. We can say, look, let 2k, which is a constant, okay, a constant, equal to a constant, basically. We're allowed to do that because it's a constant, so we can just call it anything we want, right? So 2k, we can rewrite as a. So we say, therefore, 1 over p squared will equal to the 1 over the 400, as they've got, plus then the at. Okay? So part C then, it says, given that the value of the component when t equals 1 is £10, find the time when the value is £5. So when t is 1, p is equal to £10. So we sub that in, we'll have 1 over 10 squared equals 1 over 400 plus a times 1. Okay, so there we can work out a then. So basically that'll be 1 over 100, won't it? 10 squared. Take away 1 over 400, that will equal to a. So if we work that out on the calculator, it's 1 over 100, take away 1 over 400, so we get 3 over 400. Okay, so that's my a. So I can sub that then back into there. So I've got 1 over p squared equals 1 over 400 plus 3 over 400 t. Okay, that's what a is. So sub that in. And it says find the time when the value is £5. So the value is £5, we just put £5 in here. So when p equals £5, you've got 1 over 5 squared equals 1 over 400 plus 3 over 400 t. So if I work that out, I'll just do, well, 1 over 5 squared is 1 over 25. Take away the 1 over 400 equals this. So therefore I can get my t from there, can't I? So 1 over 25. Take away then 1 over 400. So that's 3 over 80. That equals 3 over 400 t. So then all I've got to do, those 3's will actually cancel there. Take the 400 up. So 400 divided by 80 equals t. So that implies then the t will actually equal 5.